Hello guys, this is me again. In this video, we are going to do a fast review about linear simultaneous equations. Sometimes guys, we have situations like this. A system of two linear equations is when we have two lines, okay, like this, but we don't have the solutions. In this case, the solutions means that we don't have y and also we don't have x. That is that we have a simultaneous equation because we need to solve for y and x. Okay, there are three ways to find the solutions. We can find the solution by using substitution, elimination, or also by using the graphical method. We are going to start with the substitution method, so pay attention. These are the steps that we need to follow to use the substitution way. First, we need to isolate one variable. It doesn't matter if you want to isolate y or x, okay? Usually, we need to isolate the variable that is easier, okay, to isolate the variable. So, pay attention to this. Okay, number one, we need to isolate the variable. This is the easiest situation because we already have isolated the y, okay? What is the substitution method? We are going to take, well, first, let me label the equations. This is my equation 1, and this is my equation 2, okay? Equation 1, equation 2. So, number 1, solve one equation for x or y. So here, we need to choose which one is easier to isolate. In this example, obviously, we already have the y isolated, 2x plus 3. Okay, so according to the equation 1, the y is already isolated, it's by itself. So we have this, the y is isolated. Then number 2, substitute into the other equation. If we already used the first one, we are going to take this y, and we are going to use it here in the second equation, the other equation. Okay, so pay attention here. This is the substitution way. So we are going to say using, pay attention, using y from the equation 1, in the equation 2. This means take this y and use it here in the equation number 2. So here comes the trick. Here comes the substitution. We have x plus what is y. So here we are going to use what is y. So 2x plus 3, okay, equals 9. Okay, as you can see, now we only have one variable. We have x. Okay, so this means that we can solve using algebra and find x, okay, by isolating the x. Okay, so here we have the step number 2. Substitute into the other equation. This is number 2. The number 3, solve for the remaining variable. Solve in this case means isolate, in this case, the x. Okay, just as a reminder, this is y, okay? So we can solve for x. We can say, okay, this is x plus 2 times x plus 3. This is 9. Okay, so we can simplify this. We can say x plus 2x, obviously, and this is 3x plus 3 equals 9. Okay, so we have this. Let me move this. Okay, so we have this, 3x plus 3 equals 9. So the goal now is to solve for x. So we need to move this number 3, plus 3. So this is a plus 3. We need to move to the right side by using the opposite operation. So we have 3x equals 9 minus 3, because now this is the opposite operation. Then we have 3x equals 6. Finally, our x is going to be, now the opposite operation will be a division. So our x is 2. Okay, this is when we have this solve for the remaining variable. Okay, so we have done this one. Then we have solve. Now we use the result to find the other variable. If we have x equals 2, this is our x. Let me show you. This is our x. So we can use this x, this solution, to find the missing variable, in this case y. So this x, we can use it here to find y. So please pay attention here. This is like a substitution again. Let me do this here. So please, considering that y is 2 times x plus 3, and we already know the x, we can say y is 2 times 2 plus 3. Easy peasy, this is 4 plus 3, so y is 7. This is our result. Okay, so by doing this, we have x and y. So this is, use the result to find the other variable. Okay, we have this. The last one, check your solution. How can we know if these are the solutions? Okay, using the original equations. Okay, if you remember, we have equation 1, equation 2. Okay, so if we already know, let me copy the original equations. This is y equals 2x plus 3. Then x plus y equals 9. Okay, so these are the original equations. How can we know if these are the solutions? By using substitution again. If, pay attention here, where is my laser? This one. If x is 2, if this is 2, plus, what is y? 7. This has to be 9. And this is true, because 2 plus 7 is 9. Okay, so this is like 2 plus, well, let's use a different color. This is like to verify the solution. So this is 2 plus 7 equals 9. Yes, this is true. Okay, here, using the first one, using this one, we can say, what is y? According to this, y is 7. So we can say, is this 7 equals to 2 times x plus 3? So what is 2 times x? 2 times x is going to be 2 times 2. So this is a 4. So 4 plus 3. If this is true, yes, this is true. So we are super sure that these are the solutions. X equals 2, y equals 7. Guys, this is a different example. We have example number 2 using substitution. As you can see in this example, we don't have a variable already isolated. So we need to choose what would be, because this is the number 1, isolate a variable. Solve an equation for x or y. In other words, isolate x or y. Which one? We need to choose the easier one. Okay. So for example, guys, in this case, again, this is equation 1. This is equation 2. Using the equation 2, as you can see, this x, we can move the negative 2 times y to the right side by using the opposite operation. In this way, we can isolate the x. Okay, so for me, in this case, it will be easier if we isolate x using the second equation. So we can say isolating x from equation 2, from the equation 2. And this is like this. This is minus 4. So by moving this minus 4, let me see, minus 4, the opposite operation is plus 2 times y. Okay, so we have moved. This is a negative, then it becomes positive. Okay, the opposite operation. Once that we have isolated one variable, so we have done this one, the first one, we have substituted into the other equation. Okay, because we already used equation number 2, number 2, this one, we can use this x into our equation 1. So this is the next one. Using our x from the equation 2, equation 2 into the equation 1. So we are going to do the substitution. We are going to use this x into here. So pay attention, we have 11, let me see, 11 times, what is x? Minus 4 plus 2 times y. Okay, then minus 7 times y equals minus 14. So let me check. We have this. So remember, this is x. This is x. So now by doing this, we have one single variable missing in this equation, the y. So here we have substitute, yes, we have done this one. So solve for the remaining variable. So we need to solve this for y. How? We need to do some algebra. We can multiply 11 times minus 4. This is minus 44. 11 times 2 times y. This is a positive 22y. Minus 7 times y equals minus 14. Okay, so here, as you can see, we need to do some algebra. We need to identify the like terms. So the 22y minus 7y, this is 15. This is like minus 14, no, 44 plus 15y. Okay, this is the subtraction. This one, this subtraction equals minus 14. The goal at this step is to isolate y. So we need to move the negative 44 by using the opposite operation. So it's going to be a sum, addition. So this is 15y equals minus 14 plus 44. Okay, so obviously this is 30. So we have 15y equals 30. Then y is going to be 30 divided by 15. So this is 2. So y equals 2. Okay, all the steps in order to find y. Okay, so this is y. So we have this one. Solve for the remaining variable, yes. Use the result to find the other variable. We already have y. So now we need to use this y to find the x. We need to find x. Okay, this is super important, guys. If you remember, we have isolated the x from the equation 2. We can use this version, this x isolated, to find x, okay, because we already have y. So this is something like x equals minus 4 plus 2 times y. Okay, so we need to use what is y. So x is going to be minus 4 plus 2 times 2. Okay, x equals minus 4 plus 4, easy peasy, this is 0. So this is x equals 0. So we have two solutions, the y and the x. This is the number, I'll use the results. Okay, this is number 4. Number 4, yes, so check your solutions. Okay, in this case, we need to check x is 0 and then y is 2. Okay, just as a reminder here, x is 0, y is 2. Okay, so we need to substitute these values using our original equations. Okay, we can use both if you want. For example, using the first one is going to be 11 times 0 minus 7 times 2. Well, let me see, this is 11 times 0 minus 7 times 2. This has to be minus 14. And yes, this is minus 14. If we use the second equation, this is like 0 because this is x minus 2 times 2. It has to be minus 4. And yes, this is minus 4. So this is the substitution method. Now guys, continue with this video tutorial about how to solve system of linear equations. It's time to check what about with the solution by elimination. Okay, this is the second method that we have. But what is the key to understand this method? So guys, in this case, the goal, we are going to have something like this. Okay, the goal is that we need to find a constant, in this case, a constant is a number, okay, that if we multiply all the equation, for example, this equation, ax plus 14y equals 4, including this result, the 4, if we multiply all the equation times a constant, to have the same coefficient. Coefficient is the number next to the variable, okay? So for example, here we have okay, we are going to multiply, for example, this one. If we multiply the second equation times 2, this negative 7y becomes 14y. So it's going to be the same as this one, but the opposite sign, okay? So that would be the goal, to multiply by a constant to match the coefficients, but in the opposite, well, having the opposite sign, one positive, one negative. Then we are going to add or sum the equations, okay? And this will be the elimination. Okay, so let me show you this in action. So let's go to the iPad here. Let me show you. So we have solved by elimination. The goal is to multiply, well, to find a number, a coefficient, then to match the coefficient. Okay, let me show you. So this is again equation 1, equation 2. So pay attention. This, okay, they have something in common. If we multiply this negative 7 times y times 2, okay, we are going to match, we're going to have the same coefficient, in this case 14, and also with the opposite sign. Something that is super important is that we must multiply everything, something like this times 2. Okay, so multiply the equation 2. I'm going to do this, multiply the equation 2 times 2 to match the coefficient, in this case of y. Okay, so if we multiply this times 2, pay attention, we will have minus, let me use a different color, minus 12x, okay, minus 14y equals negative 20. So we have multiplied this times this, okay, times everything. So this is the equation 2. Then we are going to sum, we are going to add the equation 1. So let me copy the equation 1. This is 8x plus 14y equals 4. Then this would be an addition. Okay, if we perform this addition, guys, we will have the elimination thing, okay, because we can neutralize or cancel out this, okay, and it becomes easier. Let me show you. What would be minus 12x plus 8x? So this is negative 4, negative 4x. Then here comes the elimination thing. So this, we don't have this because this will be, this will be 0. Then equals what? Equals minus 20 plus 4. This is minus 16. So as you can see, now we have a linear equation, but we have only one variable, the x. So basically, let me copy this. This is like minus 4x equals minus 16. So we can solve for x. Okay, so by using the opposite operation, we have a multiplication. This minus 4 is multiplying, so it has to be dividing in the right side. So we have x equals minus 16 divided by minus 4. So x is going to be 4. this is x, okay? Okay, this is our x, but then we need to solve for y. We need to solve for y. So we can use this x to find the y, the missing variable. So let me move this. So let's see. We can use, for example, the equation 1. For the equation 1, the equation 1 is 8x plus 14y equals 4. Let me see. Yes, we already have x, okay? So we need to use x equals 4. So we have 8 times 4, this is x, plus 14y equals 4. Okay, so now this equation becomes a linear equation with one missing variable. So we can solve for y. So this is, okay, this is 32 plus 14y equals 4. So we need to move the positive 32 to the right side by using the opposite operation. So this is 14y equals 4 minus 32. Okay, so this 4 minus 32 is going to be, see, this is a negative 28. Okay, so we have this 14y equals to negative 28. Again, we are going to perform the opposite operation. This 14 is multiplying, so if we need to remove this 14, it has to be dividing. So we have y equals minus 28 divided by 14. And this is easy peasy. This is clearly a negative 2. Negative 2. And that's it. So now we have the two solutions, x equals 4. Okay, this is x equals 4 and y equals 2, negative 2. Negative 2. Okay, if you want to verify this, okay, you must substitute the values here, x here and y here. Okay, so for example, 8 times 4 plus 14 times minus 2. This has to be 4. Okay, so we can do it mentally. The 8 times 4 is 32. Okay, then pay attention, here we have a negative sign, so this becomes a negative number. So this is 32 minus 14 times 2, this is 28. So 32 minus 28, and this is 4. Okay, so this is the elimination method. We are going to do example number 2. Okay, here, example number 2. This is elimination. Remember, elimination. Okay, solving this by elimination. This is an example, guys, when we need to think about a number, okay, to match the coefficients, but also we can multiply times a negative number, okay? For example, this is equation 1, equation 2. So if we multiply, by the way, you can match the coefficient of this x or y's. It doesn't matter. You can choose. Okay, for example, if I multiply this equation 1 times a negative 3, we can have like minus 3x and then 3x. So we can eliminate, we can neutralize this one. Or if you prefer, we can say, okay, what about if we multiply the second equation times negative 2, to have something like this, the 2 minus 2y, then plus 2y, so we can cancel out the y. So as you prefer, okay? So for me, what I want to do is to multiply the second equation, here multiply the equation 2 times negative 2. Okay, so for me this is easier, but you can choose whatever you want. So just as a reminder, this is like times minus 2. So we have minus 6x and minus 2 times y equals minus 14. Okay, then we can copy the first one, the first equation. So we can perform this addition. And this is minus 6x plus x. This is minus 5x. Here comes the elimination thing. So here, this will be 0. Then equals what? Minus 14 plus 4, minus 10. So we can solve this equation. Let me copy the equation. This is our equation. We can solve for x. So we can say the x is going to be 10 divided by negative 5. And this is minus 2. Okay? So once that we have this x equals minus 2, we can find y by substituting this, by using this x equals 2 here. Okay, we can use, so let's do this, this one. Nope. Let's do this here. We have x plus 2 times y equals 4. Okay, so here we're going to use what is x. So this is minus 2 plus 2 times y equals 4. Okay, so we need to move this negative 2 to the right side by performing the opposite. So this is a negative number, it becomes a positive number, the addition. Okay, so we have 2 times y equals 4 plus 2. So 2 times y is going to be 6. Finally, y is 6 divided by 2. Easy peasy. This is 3. So y equals 3. And you can verify, okay, you can verify again if x is minus 2 and then y equals 3. Okay, we can verify what happens. Okay, let's use the first one. For example, this is, if this is minus 2 plus 2 times 3, okay, this has to be 4. We can check. This is 6, so it's like 6 minus 2, 4. And that's it. This means that these solutions are correct. And this is the elimination method. Okay, guys, the last method that we have is the graphical method. In this case, in order to find the solutions, remember, we are talking about 2 lines, okay, and we need to find x and y, okay? So we need to plot and graph the equations, every single equation. We're going to have 2 lines, and the point at which the 2 lines intersect, or they join together, that point would be the solution. And remember, when we have a point, always, this one, this. When we have a point, always a point has coordinates x and y. So we are going to plot the graphs to find the intersection point, to then identify what is the coordinate, the x coordinate and the y coordinate, because that would be our solutions. Okay, before, because here we have write both equations in mx plus b. I want to remember the meaning of this mx plus b. Every single line can be written like this, okay, mx plus b. In this case, in all the cases, in general, m represents the slope, the rate of change. We can say the inclination, steepness, okay? So, and remember, when the slope is positive, the line is going to be like this, upwards. For example, this is a positive slope, so the line goes upwards. When we have a negative slope, for example, minus 2x plus 1, okay? In this case, the slope is negative. The line is going to be like this, going downwards. So this is a slope. This is the m. Okay, what is b? B is the y-intercept. What is the meaning of the y-intercept? If you remember, we have two axes, the horizontal axis, the vertical axis. The y-intercept, okay, is the point at which the line, the function, remember this is, in this case, this is the function, our line, 3x plus 2, and this tell us that the line is going to cross the vertical axis at 2. So you can verify this 2 is the y-intercept because b is 2. Okay, if the y-intercept, I don't know, it's 4, the line is going to cross at here. If the v or the y-intercept is -1, the line is going to cross here. Okay, that is super important. Then, considering the slope, what is this? We were saying the slope can be positive or negative, its inclination, the steepness, but also is the rate of change. Rate of change. Pay attention to this definition because in this specific example, when we have the slope equals 3, what is the meaning? It means that for every single unit here, using the x-axis, again, every single unit in the x-axis, the rate of change is going to be 3. In other words, for every unit here using the x-axis, the vertical axis is going to change by 3. You need to check the sign because this is positive. It means for every single unit horizontally, it's going to increase vertically 3. Okay, this is super important. Again, here for every single unit is going to horizontally is going to increase by 3. Okay, we can see it here. For every single unit horizontally is going to increase by 3. This is because the slope is positive. If the slope is negative, it means that for every single unit horizontally is going to decrease by 3 because it's going downwards. Okay, we need to remember this because we are going to use this to use the graphical method. Okay, so enhance solutions by graphical method. We need to remember this. The steps: write both equations using mx plus b because this is going to be easier to plot the graphs. We need to plot both graphs, then we need to find the intersection and read the solutions. By the way, there are some times that the solutions are going to be an estimation or approximation. An approximation, okay? It depends on your graph. Because sometimes, for example, if we have a system of linear equations where the solutions are, I don't know, 1.3 x, this is x, and y is 2.34 or whatever, it's going to be very complicated to identify these points using the graphical method, okay? So let's do the example 1. So according to the steps, we need first to have both equations using this structure mx plus b. So let's change, this is 1, this is 2. So changing to mx plus b. Okay, let me delete this to mx plus b. mx plus b. Okay, so let me zoom in. This is, I'm going to do this super quick. So we have, this is the first one. This is 7. So we need to move the 2x using the opposite operation. So we can say minus 2x plus 7. Okay, this is mx plus b, a negative slope. And then the second one, we can move the x. Okay, let me see. This is ham. So again, we can move the x, and using the opposite operation would be minus x plus 4. So now we have our equation 1 and the equation 2 using the mx plus b. So what can we say about this? The first one, both equations, they have negative slopes. So they have to be something like this, going downwards. Okay, so to use this method, we can use what we know about mx plus b to draw our lines. So here I want to use blue, and this one I'm going to use red. Okay, let me plot the first one. So we have, first, for me it's easier if we want to draw the line to identify the y-intercept. In this case, this is 7. Did you remember? Okay, if we remember this one, this is the y-intercept. So we can say 7 is here. Okay, 7. Then we have two options. If we remember about what is the meaning of slope, rate of change, what is the slope? A negative 2. So this means for every single change for 1 unit here horizontally, it has to decrease 2 units like this. Again, pay attention. This is 1 unit horizontally, but the slope is negative 2. So it has to decrease 2. So this means that here, this is our next point. If we continue by doing this for 1 unit horizontally, 2 vertically downwards, this is point 2. We can continue 2 point this. Then what about the next one? From 1 unit and 1, 2. Okay, something like this. Then we can join the points like this. Okay, this is the line, the first equation. Okay, if you don't remember how to find or what is the meaning of the rate of change, you can use the x values to find the point. For example, because I want to do this one single time, we have y equals minus 2x plus 7. Okay, so to find the points, let me show you. To find the points, what happens when the x is 1? When the x is 1, we need to use 1 here, okay? Assuming that the x is 1, this will be minus 2 times 1, minus 2 times 1, obviously this is minus 2, plus 7 is 5. Okay, so in other words, when the x is 1, the y is 5. That is the reason that we have this point. We can do this again with the number 2. We can say what happens when the x is 2. And we have something like this. When the x is 2 is minus 2 times 2, minus 4, plus 7. This is a positive 3. So this means when we have x equals 2, we have y equals 3. And that is the reason that we have this point, okay? So we have two ways to find out these points and then join the points, and we have the line. Okay, so I'm going to do the same using red, okay? And then, okay, let me do this. We have minus x plus 4. This is minus x plus 4 using the red color. Okay, so again, we need to identify the y-intercept. So this is 4. 4, positive 4. What is the slope? The number, next to the x. This is like minus 1x. Okay, this is like invisible 1. So this means for every single unit horizontally, it's going to decrease because it's negative 1 unit. Again, because the slope is negative 1, remember the slope is minus 1. Here we have an invisible 1. This means for every single, where's my laser? This one. For every single unit horizontally, we have 1 unit vertically. 1 horizontally, 1 vertically, 1 horizontally, 1 vertically. Okay, By doing this, we can find the points. So the next point will be this, and this, and this, and this. So we can join the points like this. Okay, so now we have two lines. Both they have the negative slope downwards. What is the solution? Pay attention here. Find the intersection point. This is the solution. So the intersection point, we need to check what is the point where the two lines join together. Let me see if I can use green. Maybe this one. Okay, I think something happened here. Here. Okay, this is better. So this one, using the color green, this point, we need to read the coordinates. We can use S because we have solutions. The solutions would be when we have x equals 3 horizontally and y equals 1 vertically. So the solutions are x equals 3, comma, y equals 1. Okay, these would be our solutions. And you can do the same. You can take the solutions using these original equations to verify. This is, okay, this is x equals 3, y equals 1. So we can say when the x 2 times on the x is 3 plus 1, it has to be 7. And yes, 2 times 3 is 6 plus 1, 7. So our solutions are correct. Okay, this is the graphical method. And one thing that I can say here is that sometimes it's a little bit complicated to read this intersection point. For example, imagine the situation. There are some cases where the intersection point is going to be like, let me show you, like here. Imagine that I have this line, then different line. Okay, so in this case would be an estimation. We can say using an estimation, this is maybe 1.5 and the x coordinate, comma, minus 6 the y coordinate. Okay, this is possible. Okay, so that's it.